This question is asking us to sketch this area bounded by these equations and revolve it around the x-axis. So just want to make sure I know which axis we're going around. Find the volume of the solid formed by this revolution. A calculator is allowed, so we have our calculator here, so we can round to 3 decimal places after. We're given 3 functions, y equals x squared plus 4, y equals x squared plus 4, x equals negative 1, x equals 1, and y equals 3. So let's draw some of the easier ones first, and then we'll draw the final one, which is that x squared plus 4. The easy ones are x equals negative 1, x equals 1, and y equals 3. These first two are going to be vertical lines. Vertical. And this last one will be a horizontal line. And we know that because any equation that's just x equals a constant is just all those x values that are possible. For y, all those y values that are all the possible places where y will equal 3, which is a straight line. So we can draw that out. X equals negative 1, let's say, is here. And I'll write that, x equals negative 1. So x equals positive 1 would be the same distance, but on the other side. And then y equals 3 would be 1, 2, 3, right there. And now what about x squared plus 4? Well, we know that x squared is a parabola, and it's going to open up like this. And then we also know that x squared would just start at the origin. So if it's plus 4, we're just going to move up 4 units. So 1, 2, 3, 4. And so we're going to get a parabola that looks something like that. So the area that we're talking about, I'll color it in red here so we can see it a little distinctly. The area that we're going to rotate around the x-axis is right here. I'm just going to color a little bit there. There we go. And so this is going to go all the way around. I can show its reflection on the other side. It'll look something like that. And so this whole thing will rotate around and make some sort of like weird vase type thing where there's a solid thing and then there's that empty space inside. Well, how do we figure out how to calculate this integral? Well, the first thing we need to do is figure out what are our bounds for our integral, but one thing that's really nice is we know that we stop at negative 1 and 1 since we're rotating around the x-axis. We're already told that we're going from negative 1 to 1, and so I know our integral will be something set up, and I'm going to write that here, from negative 1 to 1, blah, 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 dx. But I don't know what's going to go on the inside. How do we determine that? Well, first we need to figure out what's happening on the outside of our shape. What circles are going to be made? What function's deciding that? To figure that out, we figure out which one is on top of where we're rotating. And we can see probably pretty clearly that the function that's on top, we will start at the x-axis and we'll go all the way up. That function is y equals x squared plus 4. That radius is going to tell us the whole thing on the outside before we take anything out on the inside. And so we have our radius, x squared plus 4. And what are we going to do? Well, we have to square our radius and multiply it by pi if we want to get the area of one of the circles that will go around. What if we want to find the volume of that circle? We have to multiply by the infinitely small thickness, dx. But we don't just want one circle, we want all of those circles together from negative 1 to 1, and that's why we add them up by using our integral from negative 1 to 1. So great, we have the outside portion. That's determined by y equals x squared plus 4. But what about the inside part that we want to get rid of? That's where that hole comes in the washer method, or I like to say the donut method. I'll do this one in green. We start again at the x-axis and we go to find the bottom function. In this case, our bottom function is y equals 3. That's going to give us our radius for that one that goes around. So we're going to subtract, again, the integral. We're still going from negative 1 to 1 of pi times our radius, which in this case is 3 squared dx. Oh dear, sorry about that. Ooh, there we go, now we can see everything. So we're given this again, that 3 is that radius, we square the radius because we're finding the area of a circle, and then we add up all those circles together. Now we can simplify this a little bit because I can see they both have these pi's and the same integral. So I'm going to rewrite it in blue now. Pi times the integral of negative 1 to 1 of x squared plus 4 squared minus 3 squared, which is 9, dx. And now I can use my calculator to calculate this. So I'm going to do, first put in my pi, so second pi. Math 9 to get my integral. My bounds are from negative 1 to 1. And then I have, first, I'm going to put in parentheses, this x squared plus 4. X squared plus 4. Close, and then square that, right? So now I have x squared plus 4 squared, and then minus 9. All right. We're going to enter, and we see that the volume will end up being 61.994. Don't make the mistake of forgetting that pi, which can happen to some people. I'll show you. So I'm going to hit second entry to bring that down. And then if we go all the way over here, and I hit left all the way, and I just delete the pi, that's going to be 19.733. So if you forgot the pi, which happens sometimes, you're going to get a value that's much lower than what we want. You want to remember that since we're revolving and there's circles being made, pi has to be involved, so make sure that we're including that pi in our final answer.